Hey there, this is Scott. Hope things are going great. Hey, we're going to take a look at section 7.4 today, which begins on page 319. And some of the things that we're going to talk about here, I think probably would have been beneficial with some of those problems when I look back in section 7.2 and some of the things that they had in there with all that. But what we're going to do here is talk about how to clear fractions and decimals when you're working with these types of problems. And it's I think it makes it a lot easier when you just get rid of all that stuff and you're working with just integers. And it doesn't affect your answer at all. You got to remember that because um, whatever you do to one side of the equation, you're doing to the other. So it doesn't make a difference of what's going on with all that. So it won't affect, like I said, your answer at all with any of those things too. So um, let's say, for example, let's take a look at we're going to look at two different things. What you need to do to clear out the denominators when there's fractions in there, and then also what you need to do to get rid of of, of decimals in that case too. So let's say, for example, we have something like 1/2 x plus 3 equals 3/4 x minus 4. Okay, now I had no idea what this one's going to look like when we're done, so hopefully it's a good looking problem. But what we need to do here is we need to multiply everything by the greatest common denominator. Okay, and we've kind of talked about those before in our earlier chapters. So in this case, our greatest common denominator for this problem is going to be 4 because we have a 2 in the denominator and a 4 in the denominator, so our greatest common denominator is going to be 4. So what I have to do to each side is I have to take it times 4 to get rid of that there. So if I take 4 times 1/2 x, 4 times 1/2 is 2, so I get 2x. 4 times 3 is 12. Okay, 4 times 3x, excuse me, 3/4 x, those are going to cancel out, so I end up with just 3x, and 4 times a negative 4 is a negative 16. All right, so really it's kind of that multiplication distributive property that we talked about before, except we're making it do that with all that. So as I look at this now, there's nothing else to multiply. There's no like terms that I need to combine before I do this. And like I said, I always like to subtract to the side of the larger variable. So 3 is larger than 2, so I'm going to subtract 2x from each side. And when I do that, I get 12 equals x minus 16. And now to get this one taken care of here, I have to add 16 to each side. And I get 28 equals x, because that gives us 0 right there. So my answer here, x is equal to 28 with something like this. But what you do is just multiply each side by the greatest common denominator to get rid of the fractions with that. And that's one of the biggest pieces with that too. Another thing that it talks about here, but isn't in play as much, is what do you do with decimals with that too, to make life a little bit easier. Usually, in this day and age, when you've got your calculator, it's not such a big deal with some of those pieces. However, if you don't have a calculator handy, I do want to show you one thing that will make your life easier with that too. Because once again, I like working with integers. I don't know, call me crazy, but I think that makes life a little bit easier for us. And actually, what I'm going to do here is I'm going to kind of take this same problem that we had here and just look at it in a different format. Okay, I had 1/2 x plus 3 equals 3/4 x minus 4. Okay, so instead of 1/2, I'm going to say we have 0.5x, which is 1/2, plus 3 equals 0.75x minus 4. Okay, same type idea, same problems, except instead of seeing it as a fraction, you see it now as a decimal that way. So, but what I'm going to do here is I'm going to multiply to get rid of the decimals. So because I've got decimals to the hundredths here, I have to take everything times 100. Okay. And so if I take this side times 100, I have to take this side times 100. And when I multiply it out then, oops, I should do it like this too. 100 times 0.5x, that's going to give me 50x, plus 300 And 0.75 times 100 is going to give 75x minus 400. Okay? Same idea, doing the exact same things, okay, except larger numbers that we're working with here. Same type idea now too. Want to get everything over here because I want to go to the variable that has the larger coefficient. So minus 50x from each side. So I get 300 equals 25x minus 400. Okay, and now I have to add to each side again, plus 400. 400, and so I get 700 is equal to 25x. Alright, so I've got done all my addition and subtraction pieces. Now I have to do my multiplication or division, so I divide each side by 25, divided by 25, and so if I look over here and take 25 into 700, it's going to go in here twice, it gives me 50, 2008, okay? So we're going to have x is equal to 28 here, which is the same thing as we found up here. Same exact thing. But it's a way you can clear decimals out of there too, if you want to work with just integers. This day and age, you might just want to go ahead and subtract and work with those decimals. But it's an option for you. If you take a look on page 331, page 331, there's some problems you can work with there. It's 1 through 44. 1 through 44. Now, a couple things I do want to point out to you here. Actually, I lied. It's still page 331, but the problems go instead of 44 up to 75. So that'll give you even more practice. So that'll be good that way. So, do want to point out a couple things here with solving some problems. A couple of them on page 326. Oops. On page 326 and on page 328. There's two different types of problems that you're going to be working with here in this unit and in this chapter. And there's some good examples of how you would set those pieces up. In the first one, there's some problems that you're going to work with, that you're going to try and find the amount of work each individual or machine or whatever produces when working together. So in other words, machine A does this much amount of work, machine B does this much amount, so if they work together, how much would they get done? Same type thing with that. And that's kind of how you would figure some of those pieces out that way. And there's some formulas on page 326 that will help you with that. Also on page 328, there's some on there too. And what that's saying is you've got, like this much A is doing, and then B is taking this much away. So how long does it get for a completed job? So in other words, in A they're working together. In page 326 they're working together, and on page 328 they're working opposite of each other. An example of something like that might be you're trying to fill up a pool and there's a hole in it. And so you keep adding water, but water keeps running out. So as you keep adding water, if you're adding water at a faster rate, how long will it take to fill up the pool with some of those things? So, but those are a couple of things that'll be good to take a look at too, and make sure you feel comfortable as you're doing those problems also with that in this chapter too. Also on page 329, there's a formula for simple interest that'll be beneficial for you too, as you go down the line too with all that. So that's on sections 7-4. These problems are the ones that are kind of fun, because now you're starting to put numbers into these variables into a formula that actually is being used with all that too. So I think that's kind of cool that way with all that too. So good luck, and we'll talk to you next section.